Initially, the data is represented by RGB color-coded planes weighted by measure. In this case, the measure is FA. We select a region around the corpus callosum and start the fiber tracking algorithm that works only on diffusion tensor data. At the moment, we are looking at the reconstructed fiber tracks of the area around the corpus callosum and cingulum. To explore the local information, we start the GPU ellipsoids, and now we can zoom in and locally inspect the data. We can see that we can do this real time without loss of any quality. We can zoom in and explore the data. By enabling the interactive plane, we can move through the slices until we reach the desired region of interest, and then we can furthermore explore it. We can furthermore disable the fibers and look at the local glyph information. At the moment, this information changes by changing the threshold of our classification, which means that the non-Gaussian profiles appear and disappear depending on the threshold tuning. As non-Gaussian region, we see the RGB color-coded cuboles, and in this moment we normalize them by min-max normalization, and we see that the maximum information gets a bit more enhanced. We can scale them interactively in real time. Also, we can change the thresholds, and we see that more and more non-Gaussian profiles appear. By changing the color coding, we see that more insightful information can be obtained. With yellow color are the Gaussian profiles, or the profiles that are more likely to be Gaussian, and with dark blue are the ones that can be classified as isotropic noise. We can see that even though these profiles look like clear crossings, they might come from the ventricle and can be easily masked off. Now we look at the maxima enhancement color coding, and we can see that by changing the radius, the peaks of the maxima appear more or disappear. This can be especially useful if the maximas are not that obvious. We go back to the color coding by measure, in our case GA, and we can disable the local tensor information and enable the fiber tracks. Now we can explore the gaps of the fiber tracking algorithm due to the fiber tracking threshold as a stopping criteria. Only the non-Gaussian regions, or the regions classified as non-Gaussian, are represented by the local HARDI glyph information, and now we can explore that data. We can go through a full brain slice and interactively move through the data. Specifically in this case, the data is represented by 1/3 of fiber tracks and 2/3 of HARDI data because of the classification. And now we can look at individual parts of the data and furthermore explore. At the end, we can place the fibers at seed points for the glyph visualization and verify the outcome of the fiber tracking. Now we are looking at the tensor glyphs placed on the fibers, but we could as well perform classification on these kind of seed points and see how the glyph profiles would start changing into non-Gaussian. We can furthermore inspect the data and apply the previously described interactions like min-max normalization.